So we're asked in this question, for what values of p does 2px squared minus px plus 1 equal x squared plus x have real roots? So if a quadratic equation has real roots, then the discriminant b squared minus 4ac will be greater than or equal to 0. So the first thing we have to do is we have to rewrite this quadratic equation in the form ax squared plus bx plus c equals 0, so that we can assign values to a, b, and c and use it with the discriminant formula up here. So I'm going to write down the equation as it is, and then I'm going to try and collect all of the terms on the left hand side. So what we're going to do is we're going to subtract an x squared and an x from both sides to give me 2px squared minus x squared minus px minus x plus 1 equals 0. I'm going to factorize the x squared from the first two terms to give me x squared on 2p minus 1. I'm going to factorize a plus x from the next two terms to give me minus p minus 1, and then I have my plus 1 equals 0. So we now have the quadratic equation in the correct form. So the coefficient of x squared is going to be the a, the coefficient of x is going to be the b, and the term independent of x, that's going to be c. So we're going to sub these values into the discriminant b squared minus 4ac, and we want the discriminant to be greater than or equal to 0. Remember, the discriminant is the part of the minus b formula, or the quadratic formula, that's underneath the square root. And so if the roots are real, we can't have that part of the formula be a negative number, because remember, you cannot get the square root of a negative number. So subbing in b, we have minus p minus 1 all to be squared, minus 4 on subbing in a, we have 2p minus 1, times c, we have 1, and we want this to be greater than or equal to 0. Square in a bracket, we square the first, so minus p squared is p squared. We square the last, so minus 1 squared is plus 1, and then twice the product, so minus p times minus 1 is plus p, and then times 2 is plus 2p. And then minus 4 by 2p by 1 is minus 8p, and minus 4 by minus 1 by 1 is plus 4. And again, we want this to be greater than or equal to 0. So I can see I'm going to get a quadratic inequality here, so I have p squared plus 2p minus 8p is minus 6p, plus 1 plus 4 is plus 5, and then this is greater than or equal to 0. And so how do we finish a quadratic inequality? Well, we first find the critical values by solving the quadratic equation p squared minus 6p plus 5 is equal to 0. I'm going to factorize this quadratic equation to give me p and p, 5 and 1, and we have a minus and a minus. So p is equal to 5 and p is equal to 1. So these are our critical values. So they are the roots of that quadratic equation. So we have the critical values. What we do now is we draw a graph of the quadratic p squared minus 6p plus 5. So we know that it's u-shaped in nature. And the two roots we have found, 1 and 5. We're looking for values that we could sub in that would be greater than or equal to 0. So we're looking for values that would be above the x-axis. And we can see from our graph that any p-value that would be less than or equal to 1 would give us a value greater than 0, and any p-value greater than or equal to 5 would give us a value greater than or equal to 0. So what are the values of p that would give our original quadratic equation real roots? Well, when p is less than or equal to 1, and when p is greater than or equal to 5.